This is a problem of section 4.6, variation of parameters. Here we have to find the general solution of the non-homogeneous ordinary differential equation. So, this problem cannot be solved using undetermined coefficients because of the exponent of x on the right is negative, is a negative number. So that is why we cannot solve this problem using undetermined coefficient. Then we have to use variation of parameters. So to find the general solution, recall, general solution is the sum of the complementary plus the particular. So first of all, to find the solution of the complementary, we need to write the homogeneous equation from the given. Okay, so this y double prime minus 2y prime plus y equal 0. Then this, then now we can write the auxiliary equation, and then this equation can be factored as r minus 1 squared equals 0, then r is 1. So we have 1 twice, so we have the double solution for the complementary. So the complementary is yc equals 2 c1 e to the x plus c2x e to the x. Remember, this one is an invisible one. We write in front of the x, right? One here and one here. Okay, so that is the complementary solution. Now, it is time to find the particular solution. Okay, now the particular solution is given for the right portion of the equation, which is x to negative 2 e to the x, from x to negative 2 e to the x. So remember, here we cannot apply undetermined coefficient. We cannot, because of this exponent bit negative. So what we're going to use? We're going to use variation of parameters. So variation of parameters states that the particular solution y sub p of yp is given by y1 times v1 plus y2 times v2. And what is this y1? Well, this y1, it is the first function of the complementary solution. And this y2 is the second component of the complementary solution. So what it left is to find v1 and v2. That's what we have to do now. We know that v1 prime is equal to negative f of x times y2 divided by a times y1 times y2 prime minus y1 prime times y2. Now, v2 prime is very similar. There is only one difference. The bottom is the same. The bottom is exactly the same. And the top is going to be positive as it's going to contain y1 instead of y2. Now, let's see. F of x is the left of the given equation. F of x is the left. Okay, it's x to negative 2 ex. What is the value of a? A is the coefficient of y double prime, which is 1. And then y1 is e to the x, y2 is x e to the x, and we have to find the respective derivative. Derivative of y1 prime is e to the x, derivative of y2 prime, you have to apply the product rule, so that will be derivative of x is 1 times e to the x plus derivative of e to the x times x. This is e to the x plus x e to the x. Here we applied the product rule. So now we're going to replace those expressions in the formulas to find v1 prime and v2 prime, and then we find the integrals, and then we multiply accordingly. So v1 prime, it is what? Negative x to the negative 2 e to the x, which is f of x, times y2, which is x e to the x, divided by 1 times y1. What is y1? E to the x, times y2 prime, which is e to the x, plus x e to the x, minus y1 prime, which is e to the x, times y2, which is x e to the x. So here we have on the top negative e to x to negative 1, e to 2x. On the bottom we have e to 2x plus x e to 2x minus x e to 2x. So after this, we have negative x to negative 1, e to 2x. So we have these two terms cancel, so we have e to 2x cancel. We have simply negative 1 over x, because we can move this x to negative 1 to the bottom. So v1 prime, or v1, is the integral of v1 prime dx. So it's the integral of negative 1 over x dx, which is at the end negative ln of absolute value of x. And that's our v1. Now in the same manner we have to find v2 prime. First of all we have to find v2 prime. Remember, to find v2 prime, we're going to use, so let's use different colors. Okay, so all this was for v1 prime. Well, this is v1 prime. And then once we found v1 prime and applying integration, we were able to find v1. Now it is time to find v2. So to find v2, first of all we have to find v2 prime using this formula that I'm shading now in green. Okay, so now we're going to find v2 prime. So let's find v2 prime. Recall v2 prime is f of x, which is x to negative 2 e to the x, times y1, which is e to the x, divided by the same denominator. Notice that the denominators on both formulas is the same. We found that denominator already at the time of finding v1 prime. So that is e to 2x. So this e to the x times e to the x cancel. E to 2x, same thing. We have 1 over x a second. So v2 is the integral of v2 prime dx, which is the integral of 1 over x a second dx, and this integral is going to be negative 1 over x. So let's scroll down. Bear with me. Okay. Okay. Up. So recall yp. The solution, the particular solution, is y1 times v1 plus y2 times v2. Then y1 is e to the x times v1, which is negative ln of absolute value of x, plus y2. y2 is x e to the x times v2 that we just found, and happens to be negative 1 over x. Then yp will be, we can write it as negative ln of absolute value of x times e to the x minus this x, cancel this x, e to the x. This expression is fine. Also, if you want, you can factor negative e to the x, which is ln of absolute value of x plus 1. So the general solution, which is yc plus yp, is going to be what? It's going to be c1 e to the x plus c2 x e to the x minus e to the x ln of absolute value of x plus 1. And this concludes the problem.